LLMs dream of electric sheep? It's unlikely, but the real problem is they'll confidently tell you that they do. This is a real problem with large language models, and it's called hallucinations. The models will often generate plausible sounding responses that are factually incorrect or outdated. But why does this happen? Well, LLMs aren't databases. They don't really learn continuously, and they don't know facts. Instead, these models will generate their responses by predicting the next most likely word based on their training data. And if data is missing or outdated, the model will fill in the blanks with something reasonable, because that's what their training tells them to do. Let's take an example question. How has Taylor Swift's Eras Tour been going? We'll put this through our model and receive an output. A model trained in February 2023 will have no idea about this, so we'll receive an outdated response. In this case, it's obvious to us that the model can't know the answer, but hallucinations can often slip by unnoticed, creating an issue of trust. We can't use these models if we can't trust them, and that's where Retrieval-Augmented Generation, or RAG, comes in. RAG improves LLM workflows by providing live, grounded context data. But RAG didn't always exist. It evolved over time. Originally, prompt engineers were trying to patch hallucinations with instructions like, if you do not know the answer, respond with, I don't know. But as context windows got larger, more information could be given up front, and the practice of context injection emerged. Why not give the prompt facts, figures, and tables at runtime, and then use those? The community formalized this into the 3 steps we now know as RAG. Retrieval, searching external data sources for relevant information. Augmentation, providing these sources to the prompt context window. And generation, getting the model to answer using only the given content. Let's try adding RAG to our original example. Before giving the question to the model, we'll retrieve 3 music journalism articles covering pop music. We'll then augment the prompt to include this knowledge. Finally, we generate using the model, asking it to use our sources. We'll now obtain a relevant response as the model is using the data we've provided. Rather than relying on the model's training data, RAG lets us retrieve the relevant information at the exact time we need it, allowing us to transform the model into something dynamic and correct without needing to retrain it. Retrieval can be done manually like this, but in practice, we'll look to automate it. For internet sources, we can use search APIs and web scrapers, whereas for personal documents, we can use basic keyword search or harness the power of vector embedding models to perform semantic searches. Using private documents for RAG allows us to solve another LLM issue, a lack of personalization. By retrieving internal documents like project case studies or company-specific policies, you can tailor LLM outputs to use your own data and provide hyper-specific outputs referencing data it was never trained on. Without RAG, models would remain frozen at the time of their training, unable to access recent developments or private content. They'd deliver the same generic responses to everyone, and when they're unsure, they'll fill in gaps with confident but unreliable guesses. RAG is what makes today's AI assistants both useful and trustworthy. The breakthrough wasn't to use a bigger model. It was finding a smarter way to use them. Maybe you can ask the question that leads to the next breakthrough.